Hey, it's Mr. Collins. We're looking at a third and final video on limits of a function that correspond with this handout from 16.1 in our pre-calc textbook. We've done the first 8 problems. We're going to look at number 9, 10, 11. And number 9 says the limit of that function, it's a ridiculous function, 1 over 1 plus 2 to the power negative 1 over x. They want to know what the limit is as x approaches 0 from the right and as x approaches 0 from the left. Remember, the 0 with the plus sign means the right side of 0, or numbers just above 0. 0 with the negative superscript means values just below 0, like negative 0.001. Of course, 0 is the only interesting limit you could try, because if you did plug in just the number 0, you'd get an undefined. Okay, so you'll see, and by the way, I took a second and put this into my TA84. You could also use Desmos since you're already on a computer looking at this video. And if you look at the graph, I copied it over to the right. It's kind of a goofy graph. It's got 2 branches of it. You'll notice right at 0, and by 0 I mean x equals 0, the y-axis, I'm undefined. In other words, these are, I want to emphasize, these are empty circles or holes. In other words, I can get values right up to 0, but not 0 itself. So it says verify these. So I think I'm going to use the highlighter here. Let's use Hunter Green for the Eagles. We'll use this for the right-hand limit. What's the right-hand limit? It's this branch of the function, right here. And in particular, we're saying, hey, numbers as the x's approach 0. So a values like these. See how I'm kind of cruising in there? I'll even draw a little arrow. As I cruise in from that side towards 0, the y values are closer to 1. Right? Limits are y values. We should repeat that 20 times. Limits are y values. Limits are y values. So they're saying when x approaches 0 from the right, what are the y's doing? Well, they're cruising right in here to y equals 1. Okay? And let's pick another good color here. I don't know. How about purple? Purple. We'll use purple. That'll be the left-hand limit. And if I use my purple pen here, well, hang on, let's highlight the left side of 0. And in particular, I'm saying, hey, what happens with values very close to 0? Right? Well, as I get closer and closer to 0, what are the y's doing? They're cruising in here towards the origin, which is what? That's y equals 0. That's why the limit's at 0, right? The right-hand limit, or the upper limit, is 1, right? That corresponds to this right here. And then the left-hand limit corresponds to 0. If you kind of get that, you get the graphical interpretation of limits. But that being said, let's try 2 more problems here. Number 10 looks like 4 problems, but it's really just 1 problem. It's one there, so there's one function, okay? It's computer generated. Now guess what? It's kind of implied that these graphs continue, right? So I'm going to put arrows here on the end. And what's the only interesting spot on the graph? It's right here at 1, right? Because at 1, you could say I have a break in the graph. In particular, I have a jump in the graph, and right in the middle, I have a singleton point. So, part A says, hey, what's f of 1? Well, f of 1 means when you plug in 1, what do you get? Well, you actually get 1, right? That's f of 1 is, I don't know, can I highlight this? F of 1 is this singleton point right there, right? A colored in circle indicates the graph is there or the function exists, right? So f of 1 is 1. So the ordered pair 1, 1 is part of my graph. Incidentally, this is a function because I passed the vertical line test. Even at 1, I would only hit the graph in 1 spot. That's at the point 1, 1. All right, part B, and let's keep color coding these. We'll go light green. Part B says the limit as x approaches 1 from the left. So here's the left side of 1 right there. Well, what are the y values getting closer to? Here they come. Here they come. What are they getting? Limits are y values. Limits are y values. They're getting closer to 2. So the left-hand limit at 1 is 2. Okay, look at number I almost said number 3. Letter C, right? Pick a new color here, and let's go red, right? It says the right-hand limit at 1. So I cruise into x equals 1, but from the right side of the graph. That's those points right there. So as I get closer and closer to x equals 1, where do the y's go? They're going right here. What's the y value there? It's 0, right? The right-hand limit is 0. Now, guess what? The limits, they don't come together, right? They go like this, right? They don't meet up. And if they don't meet up, if the left-hand limit doesn't equal the right-hand limit, we get our best Lindsay Lohan voice and we say, the limit does not exist. The limit does not exist. Some of you will get that joke. All right. Hey, one more just like it. We'll look at number 11. Another goofy function. I'm going to put the arrows on the end of this guy indicating they just keep going. You could see it looks like at 2, we kind of have an asymptote on the right, but right at 2, it looks like we have a function value of 0. So I guess I'll start there. We have the point 2 comma 0. You could see that's a filled in circle. So the y value there is 0. F of anything, they're saying, what's the y value? 0. 2 from the left, I don't know. Does yellow even show up here? Yeah, I guess it does. So there's the left side, right? How about a yellow pencil? Well, not so great, but you could see what I'm doing here. I guess you could see that. What are the y's values? Excuse me, what are the y's getting close to? They're getting closer and closer to 0. Yeah, I guess that picks up on the paper, right? All right, now I want the right side of 2. 2 plus, meaning the right side of 2. Let's go orange here, right? So I want these values right here. Well, this time as I get closer and closer to 2, you know, what are these orange dots doing? Well, they're going through the basement, right? Down, 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 down. It's not approaching any particular number. It's just getting infinitely negative. So negative infinity. And again, with D, right at 2, I'm approaching 2 different limits. From the left side, I'm hitting 0. From the right side, I'm going through the basement. Since they don't match up, again, we repeat after Lindsay Lohan, the limit does not exist. Okay, hope this helps. Again, if you need, I'm an email away if you are having trouble with this stuff. Take care.